What is the Big Rip? Did you know that, according to one cosmological model, the universe's matter will eventually tear apart? In this video, I will discuss one of the most famous hypothetical cosmological models, the Big Rip. Stay tuned until the end to ensure you don't miss any exciting information. Let's dive in. The Big Rip is a theoretical idea in cosmology that predicts what might happen to the universe in the distant future. According to this theory, the universe's expansion, accelerating due to dark energy, will continue to speed up. This accelerated expansion will eventually reach a point where the space-time itself is torn apart. In the Big Rip scenario, as time progresses, the force driving the universe's expansion becomes so powerful that it overwhelms all other forces, including gravity. This leads to galaxies, stars, planets, and even atomic structures being ripped apart. Everything falls apart in this process, leading the universe towards its end, where space and time no longer exist. Now, why is it so important in the world of cosmology? The Big Rip represents a possible reason for how the universe might end. Studying it helps cosmologists explore different scenarios for the universe's long-term evolution. Moreover, dark energy, the mysterious force driving the universe's accelerated expansion, plays a central role in the Big Rip hypothesis. Now, you must be wondering, what is the dark force? Dark energy is a significant force comprising around 68% of the universe's energy. It makes the universe expand faster and faster over time. Even though it has a considerable effect, dark energy is still one of the least known parts of the universe. In studying the Big Rip, scientists can gain insights into the nature and behaviour of dark energy, which remains one of the cosmos's most enigmatic components. Moving on, the Big Rip also serves as a theoretical framework to test and refine cosmological models. By comparing observational data with the predictions of the Big Rip scenario, scientists can evaluate the validity of current theories and improve our comprehension of the universe's dynamics. Now, let me share an exciting point. The Big Rip model raises profound questions about the fundamental nature of the universe. Contemplating the potential end of everything challenges our understanding of existence and prompts deeper reflection on the essential nature of reality. Let's dive more deeply into the Big Rip hypothesis. The Big Rip hypothesis is a speculative model in cosmology that proposes a dramatic end to the universe driven by the accelerating expansion caused by dark energy. According to this theory, the universe's expansion will accelerate exponentially, eventually tearing apart all cosmic structures, from galaxies and stars to atoms and subatomic particles. The Big Rip hypothesis suggests that the forces of dark energy, which is causing the universe to expand at an ever-increasing rate, will become so powerful to overcome all other forces in the universe. As dark energy's influence grows, it will lead to catastrophic events where gravitationally bound systems such as galaxy clusters, individual galaxies, star systems, and even planets will be ripped apart. The process begins with the accelerating expansion, pulling galaxies away from each other. As time progresses, the acceleration increases, leading to galaxies being torn apart as their constituent stars are separated. Eventually, stars will succumb to this force, breaking apart into their components. In the final moments before the Big Rip, even atoms and subatomic particles will be disintegrated, and the universe will no longer exist. What is the scientific basis of the Big Rip? The Big Rip hypothesis is based on how dark energy behaves. The observations show that dark energy accounts for about 68% of the universe's total energy and is the force behind its accelerated expansion. We're still unsure what dark energy is, but scientists often describe it as a constant energy spread throughout space. However, in the context of the Big Rip, dark energy is considered to have a dynamic and increasing influence over time. The Big Rip hypothesis significantly impacts our understanding of the universe's future. It provides one potential end of the universe scenario, contrasting with other theories such as the Big Crunch or heat death. Studying the Big Rip helps cosmologists explore the behaviour of dark energy and its long-term effects on the universe. If you're enjoying this video, let's subscribe to the channel to get more exciting updates. Now, let's see the process leading up to the Big Rip in detail. The first stage is accelerated expansion. The process leading to the Big Rip begins with the universe's accelerated expansion driven by dark energy. The universe is expanding, and the galaxies within it are moving away from each other. Edwin Hubble first observed the expansion of the universe based on the movement of galaxies from us in every direction. The universe's expansion speeds up in the Big Rip scenario because dark energy's influence strengthens. Dark energy acts as a repulsive force, counteracting gravity and causing the universe to expand faster. Dark energy in the form of phantom energy is more effective, leading to an exponential increase in the expansion rate. As the expansion accelerates, galaxies gravitationally bound together, like those in clusters, move apart more rapidly. The distances between galaxies increase faster, making them more isolated in space. Over billions of years, this acceleration intensifies, setting the stage for the following catastrophic events. The next stage is galaxy disintegration. As the expansion accelerates further, it reaches a point where the repulsive force of dark energy overcomes the gravitational forces that hold galaxies together. In the galaxies, everything present is the force of mutual gravitational attraction that holds them together. However, in the Big Rip scenario, this binding force becomes insufficient to counteract the expanding force of dark energy. At first, galaxies with clusters experience gravitational forces pulling them apart and causing separation. The stars within these galaxies, previously held together by gravity, drift apart as the expansion force exceeds the gravitational attraction between them. The galaxies disassemble, scattering their stars across an increasingly vast and empty universe. This stage marks a critical phase in the Big Rip process. As the structural integrity of galaxies is compromised, then the stars and galaxies are scattered. The universe becomes a more empty place when stars drift alone in space. The third stage is stellar and planetary destruction. It involves destroying individual stars, planetary systems, and even atoms. The universe is expanding at an accelerating rate, which is why dark energy becomes dominant. First, stellar systems, which include stars and their orbiting planets, moons, and other objects, are affected. The gravitational bonds that hold these systems together are broken. Planets are discarded from their parent stars, and the stars begin disintegrating. The immense pressure from dark energy tears apart the stars, causing them to explode into individual particles. As a result, the force of dark energy becomes so strong that it overcomes the electromagnetic forces that hold atoms and molecules together. Even atomic nuclei and subatomic particles are ripped apart in the final moments before the Big Rip. Now, let's discover some important information about the Big Rip. The observation and measurements, such as those from the cosmic microwave background radiation, the universe's large-scale structure, and baryon acoustic oscillations, have provided further evidence for the accelerated expansion. The cosmic microwave background is the faint glow of energy from the Big Bang. It gives a glimpse into the early universe and has played a crucial role in confirming the existence of dark energy. These observations have solidified the idea of dark energy. Despite these supportive observations, some aspects challenge the Big Rip hypothesis. For instance, current data on the equation of state parameter W for dark energy, which determines how dark energy densely evolves, suggests that W is close to -1. It corresponds to the cosmological constant while representing dark energy that remains unchanged throughout cosmic time. For the Big Rip to occur, W must be less than -1. Indicating a form of dark energy known as phantom energy that increases in density over time. However, precise W measurement is still a subject of ongoing research and debate. Now, let's look at alternative theories opposed to the Big Rip. The Big Crunch theory contrasts with the Big Rip theory. In this scenario, the universe's expansion slows down, resulting in a collapse. This could happen if the universe's density of matter and dark energy is high enough to overcome the expansion. The heat death scenario, also known as the Big Freeze, claims that the universe will continue to expand forever because of dark energy. As the universe expands, galaxies will move further apart, stars will burn out, and black holes will eventually evaporate through Hawking radiation. Over an extremely long timescale, the universe will reach a stage of maximum entropy where no thermodynamic free energy is available to do work. The Big Bounce theory suggests that the universe undergoes endless cycles of expansion and contraction. Instead of ending in a big crunch, the universe is expected to reach a maximum density and bounce back to a new expansion phase. This model claims that the universe could be eternal, undergoing endless cycles of birth, growth and collapse. These alternative theories offer different mechanisms and timelines for the universe's end compared to the Big Rip. However, if future observations reveal that dark energy's state parameter equation is less than -1, the Big Rip will remain a compelling hypothesis. There you have it. Let's recall some important points before I end the video. The Big Rip is a theoretical scenario in cosmology proposing an end to the universe driven by dark energy. According to the hypothesis, dark energy causes the universe to expand at an accelerating pace. This process unfolds in several stages. Initially, galaxies move apart faster as dark energy overcomes gravitational attraction, leading to the disintegration of galaxy clusters and eventually entire galaxies. Alternative theories such as the Big Crunch and heat death represent contrasting visions for the universe's ultimate fate, while challenging the Big Rip's predictions. Beyond its scientific implications, the Big Rip concept raises philosophical questions about existence, our place in the cosmos, and the fundamental nature of reality. Exploring the universe is an amazing idea. We should always strive to learn about its mysteries. It will not only increase our knowledge, but also allow us to appreciate unbelievable phenomena. Share your thoughts and questions in the comments section.